This is the quotient rule for differentiation. Taking the derivative of two quotient functions. So if I were to rewrite this as in polynomial form by simple division, divide everything by x squared and reduce exponents, I get 2x minus 3 plus 2x to the negative 1/2. If I take the derivative of that, I get 2 minus 4x to the negative third. Okay, let's remember that as we move down here. Now I'm going to go ahead and give you the quotient rule. If p of x equals f of x over g of x, then the derivative of p of x equals, remember our notation, derivative, we're going to really use this notation later, so let's start working with it now. I know I love prime because it's so easy to write. The derivative of px is the derivative of the top times the bottom minus the derivative of the bottom times the top. All of that over the denominator squared. Alright, so now let's just show it works and apply it to this same function. This is not going to save us any time in a polynomial function. If you see this function, please use division and divide it using the power rule. But let's take it. So we'll go the denominator squared. So I'll go the derivative of the top. This will give me 6x squared minus 6x, and that goes away, times the denominator. Then we take the derivative of the denominator, 2x, times the top, 2x cubed minus 3x squared plus 2. Alright, normally we would be done, but just to show you how it all works, let's simplify it. So that's going to equal 6x to the fourth minus 6x cubed. This will be minus 4x to the fourth. I'm going to run out of room. Plus 6x cubed minus 4x. All of that over x to the fourth. So now I see my 6x cubes cancel out. 6x to the fourth minus 4x to the fourth give us 2x to the fourth minus 4x all over x to the fourth. Cancel this out, I get 2 minus 4x to the negative 3. Same answer we got at the top. Okay, so uses for the quotient rule. Start out finding tangent lines. This is f of x, this is g of x. This is what I'm going to say is the top, this is the bottom. When I take the derivative, because I want the slope of the tangent line, I go the derivative of the top, 2, times the bottom, x plus 3, minus the derivative of the bottom, 1, times 2x minus 1, all of that over x plus 3 squared. So there's really no need to simplify, but we will. We'll go 2x plus 6 minus 2x plus 1. All of that over x plus 3 squared. My 2x's cancel out. I'm left with 5 over x plus 3 squared. So I'm looking for the tangent line at x equals -2. -2 plus 3 is 1. Squared is 1. So my slope of my tangent line is 5. So I want the equation y minus equals 5x plus 2. I need to find the y coordinate by plugging my x into the original. So I get 1 in the denominator. -2 times 2 is 4. Minus 1 is -5. So y equals -5. So y plus 5. And you are done. Alright, so now we can take the derivative of all of our trig functions. Remember, tangent is sine over cosine. Secant is 1 over cosine. So let's take the derivatives. The derivative of the numerator, sine, is cosine. Times the bottom, cosine squared. Or excuse me, cosine. It's going to be cosine squared. Minus the derivative of the denominator. The derivative of cosine is sine, so that changes into a plus. Cosine is, the derivative of cosine is negative sine, which changes our minus sign from our quotient rule into a plus. Times sine, so I've got sine squared plus cosine squared. All of that over cosine squared theta. So basically I have sine squared, or cosine squared, which, because of the Pythagorean identity, sine squared plus cosine squared equals 1. 1 over cosine squared is secant squared theta. So we know the derivative of tangent from now on is secant squared theta. You can memorize that, or you can do this every time you see it in a problem. 1 over cosine squared. Well, the derivative of the numerator is 0 times the denominator minus the derivative of cosine, which is minus sine, which turns that minus into a plus, times 1 all over cosine squared theta. This equals sine over cosine squared do some tricks with this. I'm going to get sine over cosine times 1 over sine, or 1 over cosine. So the derivative will equal tangent times secant. You can choose to memorize that. Same rules over here. Cotangent is cosine over sine. So the derivative of the numerator, derivative of cosine is minus sine, times the denominator. Minus, what's that? We have cosine squared right there. Negative sine squared theta. Derivative of sine is cosine times the numerator. What's this? Cosine squared theta. All of that over sine squared theta. So these are going to look very similar next to one each other. This is negative sine minus cosine, so it's -1 based on the Pythagorean identity. Which is negative cosecant theta. So the derivative of cotan, negative cosecant theta. Last one, cosecant. Cosecant is 1 over sine. The derivative of the top is 0. Minus derivative of sine is cosine. All of that over sine squared theta. 0. Negative cosine. Same trick I pulled over here. I'm going to go negative cosine over sine. Cosine over sine is cotan. Secant, or cosecant. So those are your rest of your 6 trig functions. Another example. Find the equation of the normal line. So the derivative of the top is 3. Times cosine theta minus the derivative of cosine, which is minus sine, changes that into a plus, all over cosine squared theta. Feel free to simplify that more if you want. I'm not going to. I'm just going to plug in my theta. I get 3 times cosine theta, or pi. I'm going to plug in my pi. Plug in pi for theta. Plus 3 pi sine pi all over cosine pi squared. Cosine of pi is -1, so I get -3 plus sine of pi is 0, so that goes away. Cosine of pi is -1, so my slope of my tangent line is -3 plus 0, which is -3. So my slope of my normal line is 1/3. So I've got y minus equals 1/3 x minus pi. We need to plug pi in our original to get y. Y equals 3 pi over cosine pi, which is -3 pi. So y plus 3 pi. And there you have it. More quotient rules. The derivative of the numerator is 2x minus 2 times the denominator, x plus 2, minus the derivative of the denominator, which is 1 times the numerator, x squared minus 2x. All of that over x plus 2 squared. Let's just see. I get 2x squared minus 2x plus 4x minus 4 minus x squared plus 2x. Not all of these will simplify. You're not going to see me simplify often. 2x minus 2x goes away. I get x squared plus 4x minus 4 all over x plus 2 squared. I bet, let's see, the top factors into, no, the top does not factor. So that's why we really didn't need that step. Alright, I'm going to cheat. I'm going to go back to my last page for this one. We said that the derivative of tan x is secant squared x. So memorizing that comes in handy here. The derivative of tan is secant squared x. Or secant squared, these are all x's, secant squared x. Times the derivative of the denominator minus the derivative of the, times the denominator minus the derivative of the denominator, which is 1, times the numerator, tan x, okay, secant squared x all of that over x plus 2 squared. There's no simplification. There you have it. Now, if you would not have remembered your tangent rule when you did that denominator, you would have to go over here and do sine over cosine theta. Derivative of sine is cosine, so that gives you cosine squared on the top, on the left, minus the derivative of cosine is sine, so that would give you sine squared on the top. That's 1 over this squared, which gives you secant squared. So you could still do it if you didn't remember your formula. Sine over 1 minus cosine. Derivative of sine is cosine. Minus the derivative of the denominator, 0. Derivative of negative cosine is plus sine, so sine times sine just to see what happens. Cosine theta minus cosine squared theta minus sine squared theta I get negative 1 here, cosine minus 1, that doesn't cancel with anything. You're good there. Next one, I get 3 minus 1 over x is, I'm going to simplify this just for myself, x plus 5. Write it in polynomial form, like so. So I go, derivative of the top is 3, and I get plus x to the negative 2 times x plus 5 minus the derivative of x plus 5, which is 1, times 3 minus x to the negative 1. All of that over x plus 5 squared. And x to the negative 1. Let's just see what happens. X to the negative 1 plus 5x to the negative 2 minus 3 plus x to the negative 1. So I get 2x to the negative 1 plus 5x to the negative 2 minus 3 all over x plus 5 squared. So you can simplify this stuff, but it doesn't really help you because you can't cancel anything. So usually if I go into derivative, well, there's the derivative right there, I'm done.